joining our developer series today, where we run a different technology each day of the week. So today is Tuesday, so we'll be covering Security Tuesday, but feel free to join us on Wednesdays for data science and AI, or Thursdays for cloud native and Red Hat OpenShift. So the topic we'll be covering today is an introduction to Kubernetes security. Keep in mind, this is a basic introduction. It's for anyone who started using Kubernetes and microservices applications, and you want to understand how do you secure your application, right? So my name is Naira Hussain. I'm a web and mobile developer from Sri Lanka based in Dubai. And with me, I have my colleague Asna, who's the lead developer advocate for Pakistan. Asna, do you want to introduce yourself?
Hi, everyone. I hope you enjoy our session today. And yeah, I'm based in Pakistan and I'm the lead developer advocate in Pakistan. So let's begin.
All right, thanks, Asna. Okay, so for today, while we're doing a basic introduction, we also have an introductory code lab for you at the end. This is optional, but if you'd like to be a part of that, you would need access to the tutorial. So it's a self-paced tutorial for the code lab. That's the first link we have on here. You would need access to an IBM Cloud account. So to do that, it would be best to do it using this link, so ibm.biz/kubesec. And the last one is, for this workshop, we also have a free Kubernetes cluster for you. So everything we're talking about during the workshop, you can go and try it out in the code lab using the free cluster, right? So you've got a free account, free cluster, and a self-paced code lab. So let's get started. Right, some initial housekeeping as well. So first, it's really important that these sessions are really beneficial to you. So we want to know what exactly you're interested in learning about next, what you liked, what you didn't like in the session, if you'd like to be a speaker. So please go ahead and fill out the survey at any point during the workshop to give us any feedback, and we'll be happy to review this later to really improve the overall experience for you. A little housekeeping about Crowdcast for those of you that are new here. So you can follow us on the IBM developer account on Crowdcast to be automatically notified of our upcoming events. You can say hi in the chat, let us know where you're joining us from. It's good to get to know everyone else in the developer community. On the bottom, you can see the Ask a Question panel. So at any point, you can drop a question in there, and we might answer it live or in the Q&A section. You will also see a polls panel over here where you can see questions from us to you, just so we understand your background, where you're coming in from, what you're hoping to get addressed in this session. And lastly, you will see this green button called Workshop Resources just below this screen. So you can see all the self-paced workshop resources for today in there, including the link, how to get your free Kubernetes cluster, and the tutorial for today. So here are the major topics that we're covering today: how security works in microservices, what are the major causes for concern, how you approach Kubernetes security, so what happens at the start when you're getting a request into the system, what are the important components of Kubernetes security, what are the attack vectors within your Kubernetes application, and lastly, the demo or the code lab with your free cluster. To get started, when you're exposing your application to external clients in a microservices application, there's lots of concern regarding the security measurements. So what are the best practices? What's the right configuration you need to do for your application? So that's what we'll be exploring in today's session. And I want to speak to you about causes of concern that developers have. So I'm going to be speaking about two reports in particular. So the first one is by StackRox. It's called the State of Containers and Kubernetes Security. And what they found, you can see on the top right over here. After receiving input from 540 respondents, they found that over 94% had experienced security incidents in the last year. So this is really concerning. We can see exposures and data breaches are happening due to misconfiguration, which is a result of human error. So this is avoidable. And this is becoming more and more common these days, right? So we can see detected misconfiguration is the #1 cause of concern with 67%. We can also see vulnerabilities, security incidents during runtime, failed audits, right? And the second report we'll be speaking about is by the Cloud Native Computing Foundation, which also surveys its community every year. So there's about 1,300 developers in its community that it surveyed. And we're seeing over here as well, security is consistently an issue. Like in the year 2019, it was the second highest issue, and in the year 2020, it's the third highest, right? I also want to speak to you about some recent incidents with famous companies when it comes to Kubernetes security. Example is from Docker Hub, right? Attackers actually managed to plant malicious images in Docker Hub last year, causing anyone who uses those images to be cryptojacked. So what does this mean? Users are actually deploying cryptocurrency miners in the form of Docker containers that then use your compute resources towards mining cryptocurrency for this attacker, right? So to avoid this, definitely changing your passwords and rolling credentials is a must. For Kubernetes specifically, you need to rotate your secrets. You need to audit images to ensure only verified images are being used to ensure security. And speaking from experience, malicious images are pretty hard to detect, especially since the container works exactly how it's supposed to. So running some extra checks that highlight any difference in behavior is required to ensure there's no hidden processes running in the background. The second example you might recognize is from Tesla. Anyone here heard of Tesla? You can just put a yes in the chat. So they were one of the earlier victims in cryptojacking because one of the Kubernetes clusters was compromised since it was not password protected. This misconfiguration helped attackers get a hold of Tesla's AWS S3 bucket credentials, which were then used to run a crypto mining script on a pod. Right? So you can see, if you're not careful about how you run your Kubernetes application in production, this can lead into some really costly errors for you and data breaches for you and your customers, right? I'm just going to put the links in the chat about these incidents so you can read about them in detail. Okay, so speaking about Kubernetes specifically, right? What are the main attack vectors? Where are malicious agents looking at attacking your Kubernetes application? So for those of you that are familiar with Kubernetes, you would know that there is a main master node and there are several worker nodes, right? So for the master node, you could have access to the etcd API, the storage. You can have access to the underlying machines or the VMs, access to the Kubernetes API or proxy in the control plane, or it could even be the traffic, right? The traffic coming in and out of the master node. That's something you want to keep an eye on because someone might intercept or modify or inject traffic. And then secondly, for the worker nodes, you have the kubelet agent, which is running in every worker node. So they might access it via the kubelet API. And of course, every worker node has its own pod. Every pod has its own containers running your application code, right? So within the code, probably the most important thing to take a look at is the vulnerability in your application code. Make sure any code you're deploying is secure. You've run it through application checks. You scanned it using Vulnerability Advisor, which is something Asna will be speaking about later. Again, take a look at the traffic that is coming into your code and going outside your code, right? So these are a few of the different areas we'll be considering today while we speak about the different components of Kubernetes security. Next thing I want you to recall for any of you with the security background is try and remember your security principles. So these are really basic and I will try explaining them to you with an analogy. So the first one is defense in depth, right? So remember to have several layers of defense against any attacks on your Kubernetes cluster, right? So if you take a concept of a castle, you might have a moat around the castle, you might have soldiers guarding the front, you might have archers on top, you might have a drawbridge which is lowered only for certain individuals. So you can see there's multiple layers of defense to protect your application, right? The second one is principle of least privilege. So always restrict access so that the different components can only access the information required they need to operate correctly, and only for a given duration of time. So in the event of your system being compromised, this actually limits the blast radius. It limits how much of your application is affected. And the third one is to limit the attack surface. So like we saw in the previous slide, all the different ways your application can be attacked. So the more complex or the bigger your application is, the more likely it will be that an attacker can find a way in, right? So we've covered the Kubernetes basics and we've covered the security principles.
I really like the castle example though.
Thanks, Asna. So if we speak about the incoming request to your Kubernetes application, it's being handled by the API server. So I'm going to be speaking to you about how do we ensure security while a request is incoming, while Asna is speaking to you about what happens once the request has hit the API server, right? So there's three main components we need to think of for security against this incoming request. So the first one is authentication. Where is this request coming from? Is the identity of the request verified? The second one is authorization. So does it have the right permissions to carry out this activity on your Kubernetes cluster? And the third one is admission controllers. So you remember about those additional checks we were speaking about in those examples? This is where you put those additional checks in the admission controller. So typically, when you get a request, it has to pass through each of these modules before the request is processed by your API server. The first one, for Kubernetes authentication, our requests can come from multiple sources. So I'm listing out a few here. They can come from external users, they can come from service accounts, from Kubernetes components, and I'm going to explain to you these 5 different strategies that we can use to start, right? To understand this, you also need to understand how request is processed. So if you look on the right over here, you can see the identity provider will reach out to the authentication plugin, which is requesting for some credentials from the provider, right? So it does have to provide the username, ID, and group, for instance, which is then verified by the authentication plugin. And either it will accept or it will reject it with a 401 error. So this is the first stage of security. So one of the ways you can handle this authentication is through client certificates. Sorry, just a second. So for client certificates, we use certificate authorities, or CAs, which will help us to create and validate certificates in the cluster. So typically we use X509 certificates, and you can see an example here about how we do this through a commands for our API server. The next one that we have is static tokens. So you can use a static authorization token or a file which can be accessed from a pod itself. So this could be a comma-separated value file or CSV file. It could have details like secret, user, UID, and the groups. But this is not a recommended authorization strategy because the tokens will lie there indefinitely. And in case your system is compromised, it might lead you to restart the API server. So while technically you can do this in a development environment, it's not recommended for production. The next one is Kubernetes also supports basic authentication. So this one is basic HTTP authentication, which you might have seen before if you're a web developer, where you require username and password as an authentication strategy. We also have tokens. So the first way of using tokens is service account tokens, right? So by default, the pods being deployed into a namespace have a default service account. So the pod makes use of a secret created out of the service account and then tries to access the functionality of the Kubernetes API server. So if you want any additional functionality to be provided, you need to create a service account. So that's what you're seeing in the example here. You're seeing kubectl create service account test. You can get the service accounts and get the secret, right? So that's the first way of using tokens with service accounts tokens. So we'll see an example later as well where we have the creation of service accounts and role bindings. When we get to authorization, I'll show you that. The last way of using tokens is webhook tokens. So it's a really easy way of authenticating incoming requests using webhook tokens. So you make a REST API call outside the cluster to identify the user, right? So we've covered the different ways you can use authentication. Usually we see tokens being used in production the most. So just to recap, so we've got the 3 different modules: authentication, authorization, admission controllers. And at this point, the request has gone through the authentication module, right? So either it has gone through or it has been rejected with a 401 error. So now for the next stage, for the authorization module, it will request some more details, which we'll see in a minute. So we're going to see the different ways how we're going to authorize the incoming request. First one would be to look at the request attributes. So find out if from the attributes passed with the request, if it's actually authorized to carry out any activities on the resource it's requesting access to, right? So we can take a look at the user, group, request, the resource it's requesting, and can it actually do get, create, patch, delete on that resource? This one is using nodes, so node level authorization. By providing permissions to the kubelet, which are the resources the kubelet would have access to either programmatically or declaratively, you can set the authentication mode to node for this to get activated. So the focus here is on the kubelet. The next one is ABAC, or attribute-based access control. So here we provide an authorization policy file. And based on the policy we've provided, we check whether the action of the incoming request, what it wants to take on the API group or the namespace, right? So in the example over here, you can see where we've provided a policy, and this policy allows a kubelet to read any pods. So you can see this one is actually difficult to maintain, and it's not recommended for production again. The next one is webhooks. So again, similar to how we used webhooks in authentication, you can also use them for authorization, right? So again, have a remote API server to check the user permissions. This one is really interesting. It's role-based access control, so RBAC. So it uses a role, which is nothing but a set of permissions, really. And you can see in this example, we have a deployment manager here on the left, which namespace it belongs to, what are the rules assigned to this role. For instance, this deployment manager can do get, list, watch, create, etc. And you can also assign the rules to a subject like a user. So this is done in role bindings, which you can see on the right. So you can see we've got a subject user, it's an employee. And you can also have cluster-wide scope for these role bindings with the cluster role and cluster role bindings. So this is actually the preferred authorization method. And now that we've gone through the first two ways of verifying an incoming request, the third one is admission control. So if you want any additional checks or controls on the incoming requests, you can do that here with admission control. So we can see on the right, if there's any changes to the image, make sure you always pull the image before you use it. Or for instance, event rate limit, you can set a time duration. So you can set these additional checks here within admission control. You just need to use the enable admissions plugin file. All right, so if you have those three modules in place, this is what your request would look like. So over here, I have an incoming API request. It goes through the authorization module, any admission controls that I have in here, validate any schema before it is being stored, right? So that's in a nutshell what happens to any incoming request once it goes through these security modules. If you have any questions, please drop them in the chat. For the next bit, Asna is going to take over and show you what happens within the Kubernetes architecture.
Thank you, Naira. I hope that was really helpful for everyone. So now I'm going to share my screen, and as Naira mentioned earlier, I will be talking about, is my screen visible, Naira? All right, guys. So let's talk about attacks, vector attacks on the Kubernetes architecture. All right. So to begin with, like we all talk about the authorization, authentication, and the structure and everything. So where exactly the vector attacks take place? So these are like the main places where our Kubernetes cluster is most vulnerable for the attacks. They can attack on the containers, on the pods, master node, worker node, and API server. So let's, without further ado, let's talk about the container image security. So just as like most of the developers, when you need to adopt to practice secure coding for application security, you also need to, ensure the security of the image layers built on top of the application. So, for example, a Java application needs a Java development kit as a base image, which in turn needs a base operating system image, even if you ensure that your own Java application is free of vulnerabilities. If the base images are not secure, right? So the container could be vulnerable to attacks. So for example, I created an application, whether it's a Java application or a Node.js application, and I see that my application is... Nari, are you able to hear me properly?
Yeah, I hear you clearly.
Okay, I'll have to switch off my screen because I think I'm having some lag. So, Okay, I hope it's fine now. All right. So again, as I said, just for example, your application you build is like super secure, but if your base image is not secure, right? Your container would is like exposed to these attacks, and it can have the vulnerability attacks. So let me just show you what I'm talking about and what exactly I'm pointing to. So here you can see that your base images are vulnerable, though your application, like the application that you created, is fine. But when your base image is not secure, right, it will be exposed to vulnerabilities, and we need to make sure that these are addressed properly. After taking the look at the diagram as I showed you, right, you can say that you need to safeguard your Docker image, and that is like it's a bit harder than normal things. So it's harder to secure it than attacking. So if you think like a hacker, it's pretty easy to you can say attack a Docker image, and it gets very difficult and very hard to secure a Docker image. And that's why it's really important that we need to secure our Docker images, because hackers just need to find one vulnerability to exploit the image, and either use that exploitation to get root privileges, okay, so to perform remote execution, or to get control of the host image, or maybe your server, your host image could be your own laptop, or maybe your computer company laptop, or anything else, right, or anywhere where your application is residing. So one of the main sources of exploitation of Docker image is a vulnerable package. So if, for example, your image contains a vulnerable package, it is more likely to, be exploited for by the attackers. So if, for example, let's take an example of a Docker image vulnerability, that is CVE 2019-5021, right? I'm giving you the exact number, and you guys can search it out, and if it's like the super advanced for you, you can definitely go and read about these things. And the user uses the vulnerable shadow package, and allows any user on hacker with shell access to elevate their privileges to root within the container. So another vulnerable package could be split 3.2.26.0, which has vulnerability that allows remote code execution. So if an attacker sends a malicious SQL command, they'll be able to uh, hack your images and attack them. It is hard to keep track of all the packages and application uses. So like you have a big application, and it's really difficult. Sometimes it gets really difficult what dependencies you have, what packages you have. So for these things, we have IBM Cloud offers a vulnerability advisor, which I'll be showing you a little bit of detail about that in going further, right? So you can use the vulnerability advisor on IBM Cloud, and it is very resourceful for scanning images you submitted to the registry and notifying you about the vulnerable packages. So they tell you how vulnerable packages can be exploited by the attackers, and how to resolve the issue. So it doesn't just tell you that your image is vulnerable or it has vulnerabilities, but it also tells you that how someone can exploit them and how exactly you can fix them. So that's a very very good tool to use, and I would suggest you all that should go and try that out. And obviously, in addition to vulnerable package, the vulnerability advisor services also tells you if there are any configuration issues that can make your image vulnerable. So overall, it's like a very good uh, resource for you to use. And you can also ensure container image security using various other commercial tools and open source tools, such as Twistlog, or you can use Core OS Clear, or you can also use Anchor. So these are like the open source tools that are available out there. And a good practice is basically testing your image with more than one tool, so you can cover all the possible vulnerabilities. I hope that explains you the basics of container image security, and how you should focus on why you should focus on container image and its security. So moving further, let's talk about master and worker node security. So even though, see, most of the cloud providers, they of Kubernetes services, take care of the node security. For example, an IBM Cloud Pro, take cares of the security of Kubernetes cluster that they're providing. But still, you should, never fully depend on any of the cloud providers for security. So as shown in the following diagram, as you can see that you need to pay attention a lot of things, right? Here you can see that even if though it is purely secure, still, you can have some kind of vulnerability attack at the root. So you need to pay attention to a couple of good practices, and Naira also mentioned few of them. So I'm just gonna, add a little bit to that. You need to make sure that the machine's operating system meets the center of internet security benchmark, right? So I'll share the link with you guys in the chat about Center of Internet Security Benchmark, so you guys know what are the guidelines and how you can secure your operating system according to those guidelines. Also, apart from that, you guys can pardon me, you guys can also practice the principle of least privilege, as Naira mentioned. You do not give your, root access to anyone. So this is like your root, and just don't give the access to just anyone, because if they have the access to root, they have access to master node and the worker node. And in even within the organization or within your team, you need to make sure that the person who doesn't, need these access should not be given. So, like the least privilege rule, this is the principle of least privilege. Moving further, you need to encrypt the worker node's file system and make it read only. So when you're working on the worker node, just make it as read only, and so that if someone does have the access, they are unable to do any changes. Also, you need to use some memory encryption to encrypt a part of the memory where the application data is loaded during runtime. So this approach is particularly important when you have more than one pod. So for example, here you guys have a couple of pods, so it's better that you encrypt your memory allocation where your files are residing. And so yeah, and on when it's like two pods were running on a single worker node. Okay, so moving further, you need to encrypt the etdc value store as well, and in the master node, so it resides in the master node. You guys can get more details about etdc. So I'll share the links with you, and I'm not going to get into details because this is just for the basics of security. So you guys can encrypt this as well, because encryption keys are mostly stored here, so you should encrypt this as well. All right, so moving further, let's talk about API server security. Now, okay, so as previously mentioned, right, the API server controls access to the cluster. So basically, it is the way into your cluster. So authentication and authorization plays an important role here at this point, and implement the authentication and access control with the identity and access management IAM. I'm sure most of you have heard about IAM. Even if you're new to Kubernetes and clusters, you definitely would have heard about IAM. Do let us know in the chat if you have heard about it before, identity and access management, and if you have not heard about it, again, let us know in the chat. And yeah, so most of the cloud providers do provide this service. IBM Cloud also provides this service, and you guys can use this, or you can also use the Kubernetes role based access control. If you want to get onto a finer a grained access control based, right, on namespace. And as you can see in this diagram side, this is like the kind you're having a role, and this is like you're giving an access to more finer ground level. So you're providing the access to API groups and the resources pod. So this is how it works, right? And this is like the basics of the API server security. So you can use either an IAM access, or you can use the Kubernetes role-based access. So moving further, let's talk about the network security. So when you're talking about the network security, mostly when you're signing up, and this is the area where that gets the vulnerability attack. So let me explain this to you in a little bit detail. So traditionally, when we were talking about, we were used to do network segmentation. So it was done by implementing physically using IP addresses, right? So in the Kubernetes world, right, or you can say the new world where we are talking about monolith application, microservices applications, and everything is on containers and clusters. Where so here what happens that the services are running as different containers in a single machine. So in this situation, what happens, you can segment a network virtually using namespace. So allowing or blocking of communication using the IP address is not efficient right now, right? So if you talk about the like you used to allow this, for example, you're allowing this and you're blocking this. So this was like the traditional way of doing it, but right now it's like really not efficient anymore. So instead, what we do is the rules are designed based on the service labels or namespaces as shown here. So it now depends on your service labels or maybe your namespace. Depending upon that, that's how you allow the rules. So if you're gonna buy a product, you allow that. If someone is trying to log into database, you need to decline that. I hope this makes sense to you guys and it's like more understandable, because in the when you used to in the monolith application, data transfer was from one function or to another. It happened on the same application process, right? But within microservices and Kubernetes, the same data transfer happens over network, which adds additional attack vectors. So this is like happening over a network. So it allows the attackers more chances to hack your application or do whatever with it. So yeah. uh, okay, so the service to service communication must be certified, right? And for that reason we can use Istio. Okay, it is an option to use. So Istio is a service mesh that implements certification and encryption, as you can see here, for pod to pod communication using mutual transport rail security. So here in this example, you guys can see that your application to application data is being transferred and you guys can use Istio. So it goes to Istio and then they have the they get the certificate and they get the encryption, and if it is accepted, then it's transferred to uh, the second application. So that's like the overall understanding of the network security. It's just the basics. We are not getting into a lot of details, and so this is how it happens. So let's move further, and today we are not going to do an entire hands-on lab, but what we are going to do is we are going to help you out with your clusters. So I'm going to give you a couple of minutes, and I want you guys to sign up or sign into IBM Cloud. Please tell me if you already have an IBM Cloud account. So let us know in the. So someone asked me, do we need to secure the data in transit within the Kubernetes network from pod to pod? Yes, you have to do that. So when you're securing the data, that's when you come to Istio, right? That's what it does. It encrypts your data. So when it's encrypted during the transition, your data is already encrypted, so it's secured. And you need to do that before transferring your data from one pod to another. So moving further, I would like you all to sign up for IBM Cloud. Sorry, I have all the links together. I sometimes forget them. So, okay, guys, I'm gonna give you a couple of minutes, and I would like you all to please sign up for IBM Cloud. If you already have an IBM Cloud account, please let us know in the poll that you have poll here that you already have the account, and kindly sign out from your existing account and just sign up. I'm going to show you how you can sign up with this link. Just click on the link. It will open a new window for you. See, I'm already logged in. I would have to no. Okay, so here it is. You will be redirected to this window, and you just need to add an email address, whatever you want to use. I will probably use my existing email ID. because I already have the account. And see, so it says this email address is already registered, and all I'm gonna do is I'm gonna click on login, and I'm gonna use this same link for logging in. So I'm gonna give you guys a couple of minutes. Please let me know in the chat if you have signed in or signed up using the link I provided. Guys, please let us know if you already have signed in for IBM Cloud. So I'm waiting for your response. If you already have the account, just use this link to sign in. If you don't have a cloud account, this is a link that will let you create a free IBM Cloud account. It's a light account. It does not require any credit card information, anything like that. Plus, it's a lifetime account. You guys can use this to, learn more about IBM Cloud and explore different things, create different applications for your own company or your product or whatever. As a developer, you want to learn more, you guys can do this. So I see a couple of yeses and thumbs up.
I have 7 people that have answered yes on the poll.
Okay, so awesome. So this is like your IBM Cloud account and the dashboard. Naira, can you share the link for the Kubernetes cluster? Okay, guys, so I'm pretty sure you all must be here on the dashboard. This is how your dashboard should look like. Your would be slightly different because I already have some services. I've been using this, but yours would be a little different because if you're like new to IBM Cloud, it will be a little different. So this is your cloud account. You need to sign in. That's it. And then what you're gonna do is the link that Naira shared in the chat. Just click on that link. It is gonna take you to a new windows, and here you need to provide the lab key that is also provided by Naira here in the chat. If you guys can see this OS lab, you're just gonna take this, add it here, and use your IBM ID, the email address that you used to create your IBM Cloud account. Just use that and you would get your free cluster. So I'm gonna use mine. Okay, and then I'm just going to click on I agree and I'm going to submit the request. This will help me get my free Kubernetes cluster. So bingo, it says you have been assigned a Kubernetes cluster, and all you have to do is you have been invited to the lab. You have to just log into your account, navigate the cluster, and select the name. So this is my account already. I'm just going to refresh this. All right, so I have to do is okay, so now all I have to do is go down here. Just give me a second. I need to take this.
Yeah, go for the Advo work account.
That's the same?
Mm-hmm.
All right. Yep, it's the same. So now, if you guys can see, I have a cluster here, and every one of you must have a cluster available here. You just need to go and check your cluster, and let's just take a look at our cluster. All right, so here is my cluster. It's normal, and I think it's working fine because it's deployed. Now, can you all let me know in the chat if you all have gotten your cluster? Okay, so I see one person got the cluster. Awesome. And what about the rest, guys? Come on.
We have two so far from the chat.
So two people has the cluster. I hope you rest of you people also work with this cluster. So this cluster is available free of cost for an entire month. So let's move to our next step then. Meanwhile, this is loading. My internet is a bit slow. Apologies for that. So I want you guys to follow your code lab that is right here. I'm going to share this link with you guys in the chat as well. So after having the cluster, all I want you guys to do is go to this. Yeah, my internet is a bit slow today. So I want you guys to go to your secure your container image using vulnerability advisor. You guys all have heard me talk about the container image vulnerabilities and why it is important to secure that, and I talked about vulnerability advisor. So that was all theoretical. What I would want you guys to do after you guys get your cluster, just go ahead and start doing this hands on. It's pretty small. You just have a couple of steps here that you guys have to follow, and then you will be able to figure out how your image is it vulnerable or not, and if it is, how you can fix those issues. So I believe that most of you have already worked with Kubernetes and are familiar with microservices and Kubernetes and everything. So just go on this lab and complete this for your hands-on. So I think that's it from our side for today. Naya, do you want to add something, or should I move on to our last
You can
slides?
continue and summarize.
All right. So, guys, I'm just gonna continue this and I'm gonna summarize it. So, the lab, again, I'm just gonna repeat this. You guys need to first sign in or sign up to your IBM Cloud accounts using this link. Then you guys can go to get your free Kubernetes cluster using this link and the key, all right, that I showed you already. And after that, you will just have to go to your Git repository, sorry, Gitbook, and just follow that hands-on. Because if you won't follow the hands-on, the understanding that you have from today's session would be lost, and it's better to always follow a hands-on and able to practice what you have learned. Okay, so let me just summarize everything. We talked about microservices and how to approach to Kubernetes security. Naira talked about that. Naira also, she discussed about the important components of Kubernetes security in detail, that were authentication, authorization, and admission controllers. She talked about webhooks and all of these things in detail. We also talked about different attack vectors, right, on the architecture, and how we can avoid them, or how we can address them. We talked about the image container image security. We talked about the master and worker node security. We talked about the API server security, where we talked about the best practices, and then at last we talked about the network security, and we mentioned Istio. That's a good approach to secure your network's communication. All right, so moving further, there is a survey link that is very important. As Naira mentioned in the beginning, we would really like to get to know, get your feedback and know how we can improve, and what is it that you really enjoyed from this session, and what more would you like to learn. Since again, I'll just want to repeat, this session was very basic for those who are new to security. So if you want to have more advanced sessions, or you want to get more in the hands-on, just let us know, and we will definitely arrange a session for you. Moving further, I'm going to share these resource lists with you guys for your understanding and other things. You guys can definitely go to Red Hat as well. If you want to learn more about that, there's our developer.ibm.com website, where we have a lot of code patterns related to Kubernetes and security in general. These are the meetup pages that you guys can follow for our upcoming webinars. And yeah, so here I wanted to announce that Call for Code 2021 is gonna start in a few days. That is on 22nd of March. Is it 22nd or 23rd, Naira?
22nd of March, which is World Water Day.
Yes. So we are going to start the call for code. And again, why you guys should participate for call for code? Well, because the winner gets 200k USDs. That's the grand prize. You get to contribute in the community, and it's for a good cause, where you can find a way how to make your world and your environment a better place to live. So it helps you with the skill building. You can learn about industry, and you can learn about technologies. You guys can develop your skills and enhance your professional career, while you guys are making a positive impact on the world, right? And other than that, you get to be a part of a big community of problem solvers, right? Basically, call for code is basically your big opportunity to enter the world of networking and meet people around the world who have similar ideas, right? Use technology for good. Since we are developers, and I believe that as a developer, we guys can make a positive impact in our world. It make it a better place for coming generations. And call for code is one of those opportunities where you can make a difference. Even the slightest difference from your side can bring a big change. So it is a social good. You fight back against the most pressing humanitarian and social issues. Last year's theme was about COVID-19. You know that COVID has brought the entire world to a halt, and last year's theme was COVID-19 and climate change. So stay tuned for this year's theme, and see how you guys can be a part of this big event. And correct me if I'm wrong, Naira. We're gonna do the announcement on Good Morning America, right?
And for anyone else who's interested in taking part in Call for Code, just follow us on our social accounts. You can find it on Facebook, on LinkedIn, on Twitter. If you follow the IBM developer or the Call for Code accounts, you would be notified on there as well.
Yes, definitely. And other than that, for those people who are more interested in Kubernetes and the security and everything, join us on Cube Summit on 2020 on from March 19 to 20th. It's a virtual event. It's free of cost. Okay, and also someone who is probably way better than us can teach you in more details about this. So yeah, definitely, if you are interested in Kubernetes, just join this session, this summit, and it will help you and take you to an entire depth of Kubernetes security, development, deployment, and so on and so forth. And yeah, if you guys want, you guys can reach out to me, and you guys can reach out to Naira on our LinkedIn, on our Twitter handles are there, and our email addresses are there. So that's it from our side for today, guys. Thank you so much for attending this session, and hopefully we will see you in other sessions, in our upcoming sessions as well. If you guys have any questions, feel free to ask us right now.
All right. Thanks for joining us, everyone. We'll see you next time.
Yep. Thank you so much, everyone. Oh, and the last announcement is that when I'll end this session, you guys can find the recording on this particular link. So you don't have to go anywhere. Just wait for a couple of seconds and the recording will be available. Thank you so much for joining us and have a lovely rest of the week. Thank you so much, Naira.